Welcome back to a new machine learning tutorial. In this tutorial, we are going to talk about extra trees classifier. We are going to talk about the logic behind the algorithm. We are going to code it. We are going to look for its parameters, and we are going to talk about how we can do hyperparameter tuning. Let's start coding.
I'm in VS Code interface right now. You can use any code editor that you want, completely up to you. And I'm going to start by closing this welcome page. I'm going to open the Explorer and I'm going to create a file like extra trees classifier. And I will go with the Jupyter notebooks in this tutorial. So I'm going to select my kernel quickly in here. Then I will say extra trees classifier. Now we can talk about the concept. Firstly, I'm going to be giving an overview of how I'm going to teach you this algorithm. Firstly, I'm going to talk about the concept. Then I'm planning to create a data. Then I'm planning to create a base model. Then I want to show you how you can do hyperparameter tuning for optimizing the model's parameters. So let's talk about the extra trees classifier. Extra trees classifier, which we can also refer as extremely randomized trees, is an ensemble learning algorithm that builds multiple decision trees using random subsets of the training data. Unlike random forest, where trees are built by selecting the best splits, extra trees uses random splits at each node, which increases diversity among the trees and can lead to better generalization. And we can write it like random splits at each node. So, more details on that. Extra trees classifier is based on the decision tree model, but it introduces more randomness by selecting split points completely at random for each tree. This randomness makes the model more robust to noise in the data and less likely to overfit. So we have steps when we are doing that. We can say like for each tree in the ensemble, firstly, a subset of features is selected randomly. Second, for each feature, a split point is chosen randomly from the feature's value range. And third, the dataset is split based on this random threshold, and the process continues recursively to build the tree like this. So, and at the next step, we are going to say the final prediction is made by aggregating the predictions from all trees. And this is how it works. So let's start coding. Firstly, I'm going to import main classification for the data creation. Import main classification. Then I'm going to import matplotlib because I'm going to visualize it simply when I create the dataset. So x and y, we are going to set them like main classification, number of samples 1000, number of features, let's say like we are going to have 20 features, number of informative is going to be 10, number of redundant is going to be 5, and what we can say is number of clusters per class 2. So this is going to be our data creation code in here, and now I'm going to make this run. Then I want to show you the x matrix we have and the y vector we have. So in here we have a binary classification problem since we have zeros and ones in our dataset. So let's visualize it quickly. We can say like plt.scatter, and we can take our x, we can say 0, then we can say x, we can say 1. I'm going to set the c as y, and I'm going to set the cover map as radius, and I'm going to give it a title like, let's say, not give a title, like we can say x label feature 1 and y label feature 2. By the way, I'm just showing you for making things a little bit clear in your mind. And here are two features in here. We have 20 of them, like at the x we have 20 features, but I just want to show you how our data looks like in here. It ranges around 3 and -3 like this, and here is our y distribution. Like you can also see the others, Like if you want to see the 15, 16, you can do this, and completely up to you. So let's create a base model. We are not going to do any kind of parameter operation. By the way, quick concept overview. Most of the machine learning models have parameters which we can optimize, and when we do that, it performs better. So I will say for the base model, we won't do any kind of parameter operation in here. Scikit-Learn.ensemble import extra trees classifier. Then I will say from Scikit-Learn.model selection import train test split. And I will say from Scikit-Learn.matrix import accuracy score. And we can also import classification report, but I don't want this video to be too long, so I'm not going to include the classification report on the model evaluation side. And we import train test split for splitting, accuracy score for evaluating the model we create. So I'm going to say xtrain, xtest, ytrain, ytest, and this is going to be equal to the train test split. I will pass x, y, and I'm going to set the test size as 0.2, which means that 20% of the data is going to be in the testing set and 80% is going to be in the training set. I have a tutorial about this train test split. You can check that video for learning the concept if you don't know, but I'm going to summarize it quickly in the case that you don't want to know, or just for remembering. So xtrain and ytrain are our training sets, and we are going to train our data with this, and we are going to test it, our model, using xtest and ytest. So we are going to be training our model with xtrain and ytrain. Then we are going to use the model for doing predictions with xtest, and we are going to compare our predictions with the ytest, which are our true values. So I'm going to initialize the model here quickly, extra trees classifier. Then I'm going to train this model using the fit method. Fit xtrain with ytrain. So now we trained our extra trees classifier. Let's make predictions with this. We can call model.predict, and we can pass xtest, and we are going to get binary values like this in array. I'm going to store them something like y predictions, and then what I'm going to do is I'm going to get the accuracy score on this using ytest, the true values we have, and y prediction. So our accuracy score is 0.89, and we are creating our data randomly. Like if I make this run again, then if I just make them all run again, we are going to get a different accuracy score in here. You can do that in this case, but in your real data sets, it's not going to be this easy to creating models. So we need to improve this performance on a real data set. So we are going to talk about the parameters extra trees classifier can take. So let's talk about its parameters. First up, we are going to talk about the number of estimators. This is the number of trees in the forest. Maximum features, the number of features to consider when looking for the best split. So I'm going to write them like this, and these are all parameters. I will say max depth for the next parameter. This is the maximum depth of each tree. I will say minimum sample split, and this is the number of samples required to split an internal node. And I will say minimum samples leaf, and this is the minimum number of samples required to be at a leaf node. And now I'm going to import grid search quickly from Scikit-Learn.grid search, not grid search, model selection, import grid search. And grid search is used for parameter tuning, and it tries all the parameter combinations and returns the best performing ones. So I will say parameter grid, and I'm going to define a parameter grid in here. I'm going to be using the same order like I explained them. So I'm going to start with number of estimators like this, and I'm going to give 50, 100, 200. I'm not going to include a lot of things in here. You can extend this list, like you can add 320. More parameters you try, the more chance that you are going to get a better model, but this requires more computational cost. So I want it to return quick, so I will do maximum features, and in here I'm going to give auto and square root. Then next up I will say max depth, and in here I'm going to give like none, 10, 20. Next I'm going to say minimum sample split, and I'm going to give values like 2, 5, 10, and I will say minimum samples leaf, and I will give values like 1, 2, and 4, like this. Now this is our parameter grid, and we are going to initialize the grid search in here. Like grid search is going to be grid search cross-validation, estimator is going to be extra trees classifier, then parameter grid is going to be parameter grid, and cross-validation, let's set it to the 5-fold. I have a tutorial on this topic too, you can just check it from the machine learning tutorials playlist I have, where I have more than 40 tutorials just like this one, and I'm going to set it like this. Now I'm going to fit it using this on training data I have, Y-train, and this can take some time. I'm going to be re-recording when this finishes. Okay, it's fitted in 22 seconds. We have our model right now, and we can check the parameters selected using grid search best parameters like this. So our best parameters selected are 100 for the number of estimators, 2 for the number split, 1 for the minimum samples leaf, square root for the maximum features, and 20 for the max step. So remember, this max step is 20. Come to here, you see that it performed better at the right side of the list, like in here. So you can extend this list in this way for trying for a better model. Like you can do this for all numerical parameters we have. Like you see 20 just at 15, 17, 19, 21, 23, 25 if you want to try to get a better model. So since we have this right now, what we can do is we can just make predictions with it right now. Grid search .predict, or we can even say best estimator .predict, and we are going to do X test like this. And now what we are going to do is we are going to save this to something like Y predictions tuned, and it's going to be equal to this, and I'm going to be calling the accuracy score using this Y prediction tuned. So our accuracy is 0.9 right now, and it was, let me quickly check, it's in here 0.86. So we improved our model's performance on predicting new values, which we can also refer as unseen data. We improved it using grid search by parameter optimization. So let's summarize what we did in this video. We started by explaining the concept in here, and we talked about the random splits at each node. Then we talked about the process behind, and I create the data. I showed you how we can create scatter plots on two features quickly, and here we are using make classification for creating the X matrix and Y vector, and our problem is binary classification problem with zeros and ones in target, and we created 1000 samples with 20 features. 10 of them are informative, 5 redundant, number of clusters per class is 2. Then next we imported accuracy score, train test split, and extra trees classifier. We used train test split for splitting our data. Our test size is 0.2, which means that 20% of our data points, which means 200, like I'm going to show you quickly, Y test 200, but Y train is going to be 800. So we set the test size as 0.2, and this is a common practice. It's 0.2, 0.25, 0.3 in the general model creation part, but it depends on your data. Then we initialize the base model, we train the model, and then we make predictions with it and compare it with the real values. And our accuracy is 0.86 in the base model. Then we talked about the parameters the model has. Then we imported grid search for parameter tuning. We saw how we can define a parameter grid like this. We set the grid search and we trained the models. We find the best parameters performing, and I showed you how we can extend these lists. Like in the best performing way, you can extend this list in here. Then we make predictions with the grid search we have. Then our accuracy is 0.9, which means that we improve the model performance by using parameter tuning.
Thanks for watching this tutorial on extra trees classifier. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach to that playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more. Have a great day.